Welcome to Brain Vision.
Two blocks with masses MA and MB both are equal. Both masses are equal in magnitude. So MA is equal to MB and MB is equal to 1.50 kilogram. Well, the force constant of the ship ring is 1.75 Newton per centimeter, right? So it's 1.75. So K is equal to 1.75 Newton per centimeter. Well, that is equal to 175 Newton per meter. And the spring is compressed a distance x is equal to 20.0 centimeter, and that is equal to 0.20 meter from its original length. Well, we know that the total momentum of a system is the vector sum of the momenta of the individual particles that make up the system. So total momentum P is equal to PA plus PB and so on. Let's call this equation number 1. And we know that momentum P is given by mass times velocity. Well, let's call this equation number 2. And for an isolated system, total momentum of the system is constant, right? So it's a constant, it does not change. Well, now let's do calculations. Now we do calculations. Well, since there is a negligible friction between the masses and the table, then the system is an isolated system. And assuming that the ship ring does not recoil and its center of mass does not move after releasing it, then the momentum of the ship ring still zero before and after releasing it. Well, we also know that the system is initially at rest, so the momentum of the system before releasing the ship ring is P1, and that is equal to 0. And applying the conservation of momentum, P2 is also 0. Let's call this equation number 3. Well, applying equation 2 to the two masses, right? So PA2 is equal to mass of A times VA2, right? And PB2 is equal to mass of P times VB2. And from equation number 1 and equation number 3, we get P2 is equal to PA2 plus PB2 is equal to 0. And further, we have M times MA times VA2 plus MB times VB2 is equal to 0. Since we know that mass of block A is equal to mass of block B, therefore VA2 is equal to VB2. Let's call this R1. Well, from the conservation of energy, the elastic potential energy stored in the ship ring will be converted into kinetic energy of the system. So we have, right, elastic potential energy for 1 is equal to K2, and K2 is equal to Ka2 plus kinetic energy B2, right? And now elastic potential energy is given by half kx square, that is equal to 1 divided by 2 times mass of block A times V2A square plus 1 divided by 2 times mass of B times V2B square. And we know that mass of A is equal to mass of B. So we have 1 divided by 2 times kx square is equal to ma times v2a square. And now substituting mass of a, k, and x, we have 1 divided by 2 into 175 into 0.20 whole square is equal to 1.50 times v2a square. So v2a is equal to root 175 multiplied by 0.20 whole square divided by 2 times 1.50, that is equal to 1.53 meter per second, right? So we have VA2 A2 is equal to 1.53 meter per second, and VB2 is equal to minus 1.53 meter per second.